I'm going to take sort of a slightly different tack to Ewan, and we did conspire before this to make sure that we weren't overlapping with the information we were giving, I guess, too much. So I will have a little bit more of a focus on not the prediction side of things, but more what this means for racehorse injury pathogenesis and prevention. So essentially, I'll go through the pathogenesis, the surface risk factors that we know to date from the meta-analysis study that I did about 5 years ago now, injury prevention, and then a little bit on jurisdictional differences between the US, Australia, and Hong Kong, mostly because most of the work I've done is from those 3 countries. And then I'll delve a little bit into a little bit of detail on what the Australian racetrack surfaces and ratings and measurements that we take are. So this slide is ripped directly from our workshop, Nick, on our jockey safety workshop back in 2018, where we wanted to standardise the jockey fall and injury data. So I'm using this exact same slide to remind us why we're collecting this data in the first place. And of course, it is to assist us in consistent maintenance of racing surfaces and for assessment of surface conditions, and for best practice for your new maintenance quality system data. But also, this level of data collection proposed for the US is likely not feasible in Australia, or at least not at this very minute, because of our differences in the structure of our race programming, which I'll get into a little bit later. But we can certainly, as Ewan has gone into in quite a lot of detail, learn from our previous attempts at collecting large amounts of very detailed data and what's happened in the past, where we basically have chunks of missing data, inconsistent reporting of data, and huge difficulties in cleaning those data sets because they're so massive and they're not consistently updated. So we've got a real, I guess the focus is, as Ewan went in, is that we don't need to collect everything. We need to figure out what is the most important or the key measures to collect at this point in time, and we can add to them over time. But I don't think we should start out with a big data fishing expedition. So what do we have now? What is the best available data under practical conditions? And to keep circling back to that. But first, to understand what data we need, we also need to understand the pathways to injury, and how we consider how this data on our track surfaces informs our understanding of injury risk. And there are at least 3 pathways to bone injury. One that I think pops up in the media more often than we'd ever like it to is from a single load that exceeds the bone's ultimate stress level, essentially traumatic injuries. We've had them in the past where a horse kicks a fence, for example, but these are very, very rare and very difficult to predict. More common are those that occur early in a training period at relatively low levels of training intensity, and that is loading of the bone of unadapted or de-adapted bone, particularly coming back after a layup, for example, or for horses starting their career. And 3 during periods of intense training, and that's those that generally occur in older horses further along in their career, and that's the accumulation of bone microdamage that hasn't had chance to repair because they haven't been given enough layups or rest periods. This graph is from Adeline's paper actually recently that was published last year, and we see in this study of injury risk in a cohort of Tasmanian horses that this really mirrors what we know about the injury pathways. So where the hazard of injury was highest, it was at their second career race start, where the loading is introduced too rapidly to quite poorly adapted skeleton. And then we see another spike in the hazard rate for injury. It decreases and then increases at about the 15th race start, where the racing or training in exercise intensity starts to exceed the capacity an already well-adapted skeleton. So, you know, those injuries occur later in the horse's career. So it mirrors what we know about those injury pathways. They either happen earlier on in unadapted bone, or they happen later in adapted bone, where we see quite a lot of microdamage accumulating. Now, track surface is often blamed as the culprit by trainers and in the media, because it's often one of the only factors we see on that race day when that injury occurs, and that is evident to us at that time of the injury. However, we cannot, as Ewan has mentioned, we cannot assess this in isolation. Track surface can't be assessed in isolation, and we know that most injuries are due to an accumulation of microdamage from high-speed exercise, but many factors, so multifactorial, as Ewan mentioned, influence the pathogenesis of injury. But it is often only that, you know, that most evident factor that we see when that injury occurs that makes us think maybe that's the cause. But in reality, the cause is multifactorial. Many, many things contributed to that injury occurring. So back 5 years ago, we conducted a meta-analysis on catastrophic musculoskeletal injuries. It was included a systematic search of relevant literature that was published from 1990 to 2017. And we looked at more than 60 studies. 21 of those studies looked at incidence rates for catastrophic musculoskeletal injuries, and 65 of those studies looked at risk factors for catastrophic musculoskeletal injury or fatal injury. And we delved deeper into those key factors that were significant in univariable or multivariable analysis in at least 2 studies, and found that almost 300 factors related to racehorse injury had been investigated in the past. So a huge number. Factors that we've found to have consistent evidence of risk included horses of older age, those that started racing at an older age, male sex, particularly entires, those that race in higher race classes, but also those that race in lower race classes. So a little bit of a quadratic thing happening there, where we have some claimers at high risk, but also we have group horses at high risk. Factors that relate to the race that the horse competes in, such as longer race distances or races with a greater number of starters, and factors that are related to the horse's management, including the more time since their previous race start, so they've had quite a lot of time off, indicative of perhaps an injury occurring that they needed to rest for, a greater number of race starts and a longer career length, but also key risk factors that are due to the horse likely having a pre-existing condition, including problems identified at pre-race examination, previous injuries, and recent administration of medication or injections. So all of those have been found in multiple studies, so are confirmed in multiple studies to be high risk. I know this is a little bit of a complicated graph, so I'll walk us through it a little bit. But if we look at just those studies that investigated track surfaces as a risk factor, we can see how conflicting they are. Those little black points are the mean odds ratio of risk. So those that fall to the right of the line mean that it was higher risk. And those that fall to the left of the line mean that they were lower risk. So as we can see, when we're looking at comparing turf track surfaces versus dirt track surfaces, most of them fall to the right-hand side, meaning that dirt surfaces were found to be more significantly associated with catastrophic musculoskeletal injury. But there was a study and some studies that weren't found to be significant. And we can see when we pulled all of that information together, and obviously it's from many different jurisdictions as well, that it in fact is not significant overall. But when we insert what we know about the track conditions into it, for example, turf track surfaces versus an off dirt, so muddy or sloppy conditions, we can see two studies that found one that was not quite significant, and one, the Georgopoulos and Parkin study back in 2016 and 2017, that found that it was slightly greater risk. And then no significant difference between turf versus synthetic or all-weather. But of course, we see the opposite result again with the Georgopoulos and Parkin study compared to Rosnowski, which was in Hong Kong. Rosnowski, which was the UK study, and Sun, which was the Hong Kong study. So we can see how conflicting all of these studies are, and it's very difficult for us to then say which is safer than another, which track surface is safer than another track surface, because we have conducted multiple studies over 3 decades and they all say different things. So very helpful. So these studies found no differences in risk of CMI between turf and all-weather or synthetic tracks or turf and dirt tracks, but off-track conditions were higher risk than turf. And remember that this is pooled studies. This is not just one study. And thus we know that track surface is therefore not independent of track condition. We need to look at those things in unison. For track surface track condition risk, we found that studies that investigated the effects of track condition where pooled were predominantly for turf conditions, because we have much better information on the scale condition of turf. Found that in 3 studies that racehorses racing on muddy or sloppy dirt tracks were more likely to sustain catastrophic musculoskeletal injury. And we found that 9 studies found that faster turf tracks were higher risk for fatal and non-fatal fracture, MSI, CMI, and fatality, fatal distal limb fracture, and fatal lateral condylar fracture. And we found another 6 studies where no difference was found at all. Some of these studies were lower had fewer observations, but still, we're still finding some studies that don't find any difference in risk. What's really, really important to consider is why we are more likely to observe catastrophic events under these conditions. And it is a possibility, and it's likely that it's because they exceed the limits of stress towards the end of a horse's bone fatigue life under those conditions. And we can speculate this because we know that the majority of horses that sustained catastrophic injuries had pre-existing pathology at post-mortem. So these injuries didn't just happen on that race day. They have taken weeks and months to accumulate the damage for these injuries to occur. So, for example, if we had a fast turf track and observed a catastrophic musculoskeletal injury, but on that day decided that we could prepare a more forgiving turf track, perhaps that horse wouldn't sustain an injury that day, but the injury had still developed. So that horse might go back, and 2 days later in training, it might sustain that catastrophic injury, or it might have pulled up lame from the race instead of sustaining a catastrophic injury. So it's possible that these injuries could have occurred, later in time, or that there was an opportunity for detection and for us to intervene and then send that horse out to rest before it comes back. So what's really important is that just because we're observing these injuries on that day doesn't mean that those injuries, they've taken some time to develop. It's not the track condition, particularly on that day, that was the final cause. So this is from some of our biomechanical studies here, testing compressive fatigue life of subchondral bone of the metacarpal condyles in thoroughbred racehorses. And we can see here that speed corresponds to the load on a horse's limb. So horses traveling at much faster speeds, they take on higher loads, but they'll take fewer strides before they reach failure. And then conversely, the slower the horse or less of the load that they're carrying, the more strides it will take before failure. So we found that racehorse stride characteristics and speed in another study conducted by Ashley Morris-West here, are also influenced by a bunch of things. They're influenced by weight carried, they're influenced by the horse sex, particularly male entire sex, influenced by race distance, the class of the race, and of course the track conditions. So a firmer track will produce faster speeds, and thus a horse will take fewer strides before it hits its bone fatigue life and sustains an injury. So if we continue to race a horse on a very firm surface over time and we don't give that horse rest, it will have adapted to that condition, but if we don't give it the horse rest, the damage will accumulate and we will eventually see a catastrophic injury. So what do we need to do to prevent these injuries, and where does this take us on how we understand the interaction with track condition? So we need to adapt the skeleton to what it needs to do, and that is adapting it to the speed that it needs to go and adapting it to the surface that it's going to be racing or training on. So we need to ensure the horse is training on similar surfaces to which it will race, and gradually work up to speeds and distances required to race. We don't want to make too many changes at a time. If we're increasing the speed, we don't want to concurrently increase the distance work or change to a different surface. We want to limit the accumulation of the bone damage, and we can do that by reducing the cycles of load, so reducing the amount of time that we're training, the number of strides or distance worked. And we want to reduce the magnitude of the load, and we can do that by reducing the weight carried and slowing speed, for example. I won't cover it too much here, but we want to maximize bone repair, and that is either reducing training intensity or providing regular rest periods. And we want to monitor closely and adapt as necessary, and this includes understanding the surfaces the horse is training and racing on and adapting to those if we're seeing any issues. So I'll swing back to what we've found in our meta-analysis study, again, in terms of the differences in incidence rates of fatal and catastrophic musculoskeletal injuries across jurisdictions. We can see in Australia and New Zealand, this is quite low at 0.4 CMIs per 1,000 flat race starts. In the US, 1.6, and as Ewan has mentioned, this has decreased significantly to, I think, about 1.2 or 1.25 over the last few years. And in the UK, 0.8. So there are numerous differences we can see between these jurisdictions that may explain these differences in risk, but we're likely to find it very difficult to compare our Australian tracks, for example, with the US tracks or with the UK tracks, simply because Australia, for example, predominantly races on turf, whereas America predominantly races on turf. But we can use some of that information to inform us about our injury risk. And Hong Kong was 0.6, so low also. So I'm just going to go through some of those differences we see and then why this might be difficult to standardize jurisdictionally. I think the US will actually be leading the way with this. As Ewan has said, other jurisdictions are collecting that data, but we're collecting it on quite a low level, generally one measurement per race meeting rather than lots that are being put into a database. So this, I think with the US, this will be our kind of first foray into trying to collect this amount of data on track types and track conditions. So in the US, we have race meetings. So for example, in New York, they're scheduled over just 1 or 2 months. Some race meetings I know in other parts of the country, can be up to 6 months or even longer perhaps. But generally these horses ship into these places and they train at these facilities and they race at these facilities and then they move on to the next. In Hong Kong, they only have 2 tracks that have races, Happy Valley on the turf and Sha Tin, which has both a turf and an all-weather surface. And they generally alternate between these every 3 to 4 days. So the horses will be all training at Sha Tin, and they'll either race at Sha Tin or they'll travel to Happy Valley to race, and then they'll come back and train at Sha Tin. So, and then some of them are also training out at Conghua in China. So we've got a very, very limited number of training facilities that we need to control. And this is why Hong Kong's data set is so comprehensive, is because they have quite a lot of control and regulatory control over what their horses are doing and where those horses are going. So in terms of being able to collect good data on tracks and changes in track conditions, Hong Kong would actually be much easier to do that for, because we're at just two or three facilities at Happy Valley, Sha Tin and Conghua. In Australia, it gets incredibly complicated because horses travel all across the state and sometimes further, on average every 2 weeks, to compete. And they race predominantly on turf. We do have some synthetics and we do have some sand dirt mixes, which are more in the country. But essentially, this is just a week's scheduling in Victoria alone. With we just have race days. We don't have race meetings, similar to Hong Kong. They just have race days. So they will train at one facility. So, for example, horses that are training at Flemington, they might travel all over. If they're lower level horses, they're likely to travel all over. They might go to Pakenham 1 week, and then 2 weeks later they might go to Werribee, and then 2 weeks later they might go to Mornington. So they're traveling, potentially 30 minutes to 4 hours to these race meetings. And to give you an idea of that, these are the 55 primary racetracks in Victoria. So overall in Australia, we have 325 racetracks, which I think is similar to the US. But yes, we have much fewer states than the US, obviously. So in just Victoria alone, we have 55 primary tracks, and they race at different intervals from approximately every 2 weeks to once a year, typically on New Year's Day, for example. So it would be very difficult for us to collect high levels of data consistently from some of these places that don't have full-time staff. And Mackenzie can attest to that.
Yep.
It is starkly different, and some of these track managers are probably only going out there in the morning to check that the irrigation's on, and then they go home. And some of them are just there to make sure everything's safe for morning track work, and then they might run a water truck over it, and then they might go home. But they don't generally have large teams that work on these tracks. They're usually just 1 to a handful of people. So looking at the horse starts jurisdictionally and why this might also influence our injury risk jurisdictionally is that we can see very similar patterns in their horse career and race starts, where in the US, the lower level horses, and I've just pulled an example of one horse, just a maiden claimer who would go around to each race meeting and then have several race starts at that race meeting. When I looked up some of the group horses, it's quite different. They race much, much less often, and they will just generally have the one big group race at one meeting. So they might just be training at aqueducts, but their preparation is really just leading up to one big race, Mage, for example. If we look at Hong Kong, very similar to how their race days are conducted. This one particular horse in the 23-24 season raced at Happy Valley, then Sha Tin, and then kept racing at Sha Tin every couple of weeks, then back to Happy Valley and back at Sha Tin. And in Australia, another example, this is just one horse that raced at Kilmore, Echuca, Flemington, Sandown Lakeside, Geelong, Sandown Hillside, and then Moonee Valley. So all within, if we look at the end of the year, October 2023 to February 2024, raced at 1, 2, 3, 4, 5, 6 different tracks within only 2 or 3 months period, even though that horse would have likely been being trained at the one facility. So we can see how different those jurisdictional differences will influence how a horse is basically adapting to different types of conditions that it's being asked to do. So keeping tracks, I think, standardized across the board would be very helpful for this, but we can see in Hong Kong and Australia, we have some of the lowest fatality rates and the lowest catastrophic musculoskeletal injury rates globally. And we have quite different patterns of racing than the US does. So if I go into the what we're collecting, our Victorian daily measurements, penetrometer is nearly all tracks are collecting using the penetrometer. A handful using the going stick, particularly Flemington, I think, because we do have some international horses coming in, especially from the UK, so it's helpful to have both of those. They don't report just one, they report both the penetrometer and going stick. So, but instruments are varied for daily monitoring of those track conditions. We don't at all use the Vienna surface tester, the ground penetrating radar or the OBST, but we do look at ground penetration or cushion depth, moisture content, shear surface and temperature measurements. But these were very, very varied over 15 of the tracks we looked at with Mackenzie from those 55. So there was not, there was not in any way a standardized way of doing so. Just on the penetrometer reading, I think we do it similar to the US. We take 30 measurements overall at 3 different rails positions. Our rail positions, I think, are 1 meter, 3 meter, and 6 meter, which is pretty similar, converting to your 3 feet, 10 feet, 15 feet, approximately. And we take that at 10 different locations around the track at 200 meter sectionals, which is 200 meters is roughly equal to 1 furlong. So I think we're collecting our penetrometer readings in similar ways, but in the database, we're not entering all of that data. So in the database, they use the calculation to average it out, but that gives us an average reading of the entire course, but it doesn't really give us information about the variation in that course, which I think is very, very important. And this is an anonymous quote from one of our track managers here, that essentially when tracks don't use penetrometers, the answer is a pineapple, meaning it just means nothing without an objective measurement on the track, which we sometimes rarely use. It means nothing. So I'll just, some of this will be a bit dry because I'll go into just the last few slides are our deadlines and how much information we're actually collecting. So the information that's going out publicly is just on the track type, track condition. You can see the gaps there in penetrometer reading. We get the weather forecast, rail position and irrigation and rainfall in the last 24 hours and last week. We update those penetrometer readings about a week out when nominations close, and about 2 to 3 days out when acceptances close, and then the day prior to the race, and then the morning of the race at about 7 a.m. And because we've just got race days, it's really only that week leading up to the race where any of that information is collected on a consistent form. Now, we used to have the old scale, which was prior to 2014. We've now updated that and updated we now don't race on a firm 1 or 2. They will not allowed racing to commence. if at the start of the race meeting it is rated grade 1 or 2 firm. And the clubs should be preparing their tracks from 2019 onward. We updated that to they should be preparing their track at a good 4 for flat racing, and we do jumps racing here as well, a soft 5 for jumps racing. So essentially, even if we have a hot windy day, yes, it will probably dry out over that race meeting, but if we at least start on a good 4, then we have some give in the track. We're not racing on concrete. And I think Chris Riggs will cover this earlier. I think in 2022, New Zealand's track ratings started to align, updated theirs as well so that they aligned with ours. But New Zealand also include penetrometer classifications and bands for each track rating. If we look quickly at Hong Kong, theirs is completely different altogether, and they do include penetrometer bands. So we can't even really reliably compare our scale. We've got a 10 scale track grading, and Hong Kong have an 8 scale that is based on mostly on penetrometer readings, but also on the jockey's opinion, the turf surface, and the weather conditions are also taken into account. We have good, very, very good weather data, rainfall, temperature, wind, air pressure, all of which is pretty much publicly available or available at greater resolution for fairly small costs. And for some of it, not all of it, collected at 1 minute intervals, half hourly, 3 hourly, daily, and monthly. But again, as Ewan commented, he and I are the type of people that would get this data, and it takes a long time to try and figure out how to condense it into a usable format, and to have the computing power as well to be able to do that. It's data resolution at that level is incredibly difficult to deal with computationally. But we don't, on our 55 tracks, we don't have weather stations on all of them. So they did range from those on track. Geelong has a weather station on track, but some of them, the closest weather station is about 15 kilometres away. So what do we know? We know that we've identified risk factors from track surfaces and conditions are conflicting, and these conflicts are likely due to jurisdictional differences. The track measures also are not standardised within or between jurisdictions, and our track conditions can't be studied in isolation from our other known risk factors. We know that track condition isn't the only thing that's contributing to risk of injury. And really, really importantly, the condition of a track on any one given day might exacerbate an injury, but is not the cause. So in future, would like to, to be able to link this track data to our racehorse speed and stride data. That's a whole other talk that I could go into, but essentially we are getting very good stride characteristics, speed data, and GPS data. It is very difficult to deal with because it's such a big data set, but linking that information to the track data would be very beneficial, because essentially we know that the track condition and the track surface influences the horse's speed and influences its stride characteristics. I would suggest that we sort of start out not with trying to get as much data as we can from all of the tracks, but perhaps piloting it on a smaller number of tracks to determine what key factors are important before rolling it out across a jurisdiction. And I think, your mix already got so much data sort of ready to go with trying to determine which ones are important to collect. So we should be considering, what is important and what is practical, and really beware of a data fishing expedition, because that can create difficulties with essentially having large amounts of missing data or holes in the data, and difficulty actually cleaning it and turning it into a format that is analyzable. So if we can figure those sort of things out before we collect too much, I think that will be that will put our best foot forward, I think. Yeah, thank you.